Water. It's everywhere on our planet. From vast oceans to tiny dewdrops, water is essential for life as we know it. Without water, there would be no plants, no animals, no humans. Our very existence is intertwined with this remarkable substance. Think about our own bodies. We are mostly water, about 70% in fact. Water flows through our veins, carrying nutrients and oxygen. It helps regulate our temperature and flush out waste products. Water is literally the lifeblood of our planet. But water is more than just a necessity for life. It's also a source of endless fascination. Water can exist in 3 states: liquid, solid, ice, and gas, steam. It carves out canyons, shapes mountains, and creates breathtaking landscapes. So, let's dive deeper into the science of water and uncover the secrets behind this extraordinary substance. At room temperature, water exists primarily as a liquid. But why is this the case? Why isn't water always ice or steam? The answer lies in the unique properties of water molecules. A water molecule is made up of 1 oxygen atom and 2 hydrogen atoms, bonded together in a special way. This arrangement gives water molecules a slightly positive charge at one end and a slightly negative charge at the other. These opposite charges attract each other, creating a weak bond called a hydrogen bond. Hydrogen bonds are responsible for many of water's unusual properties, including its liquid state at room temperature. These bonds are strong enough to hold water molecules together, but weak enough to allow them to move around and flow. That's why water can take the shape of its container and why it feels wet to the touch. Water's ability to transform between liquid, solid, and gas states is another fascinating aspect of this substance. These transformations are driven by changes in temperature and pressure. When water cools to 0 degrees Celsius, 32 degrees Fahrenheit, it freezes and becomes ice. As water freezes, the hydrogen bonds between molecules become more rigid, locking the molecules into a fixed, crystalline structure. This structure is less dense than liquid water, which is why ice floats. On the other hand, when water is heated to 100 degrees Celsius, 212 degrees Fahrenheit, it boils and turns into steam. The added heat energy causes the water molecules to move faster and break free from their hydrogen bonds, transforming into a gas. Section 4. The dance of atoms, how water behaves. The behavior of water molecules changes with temperature, leading to the expansion and contraction of water. This phenomenon has significant implications for life on Earth. As water cools, its molecules slow down and the hydrogen bonds become stronger, pulling the molecules closer together. This causes water to contract in volume until it reaches its maximum density at 4 degrees Celsius or 39.2 degrees Fahrenheit. However, as water cools further and freezes into ice, the hydrogen bonds lock the molecules into a hexagonal lattice structure. This structure creates empty spaces between the molecules, causing ice to expand and become less dense than liquid water. Section 5. The many faces of water. Water is a master of disguise, taking on many forms in nature. We've already discussed liquid water, ice, and steam, but there are other fascinating forms to consider. Snow, for instance, is formed when water vapor in the atmosphere freezes directly into ice crystals. These crystals often have intricate, hexagonal shapes, reflecting the underlying molecular structure of ice. H2O is simply the chemical formula for water, representing 2 hydrogen atoms bonded to 1 oxygen atom. This formula is a universal language that scientists use to describe this essential molecule. Section 6. Earth's liquid treasure. Sources of water. Water covers approximately 71% of Earth's surface, but where did all this water come from? The origins of Earth's water are still a subject of scientific debate, but several theories exist. One theory suggests that water was present in the rocks that formed our planet billions of years ago. As Earth cooled, this water was released from the rocks and formed oceans. Another theory proposes that water was delivered to Earth by comets and asteroids that bombarded our planet in its early history. These icy bodies could have deposited vast amounts of water, contributing to the formation of our oceans.